Okay, so in this video we're going to talk about thermodynamics 2b, which is related to the understanding of the methods of heat transfer. Now, this is something that you're probably somewhat familiar with because you typically learn about different ways of heat transfer in other science classes before you take physics. Okay, and so hopefully this is just reviewed to you. Now, we've talked about heat before. Remember that you can transfer thermal energy to or from an object by basically transferring heat, and the symbol for heat is that Q. Naturally, heat tends to flow from hot to cold because of the second law of thermodynamics like we've talked about before. And so generally, if you take two objects and one of them is hotter than the other, heat is naturally going to transfer from hot to cold until they reach thermal equilibrium. In other words, they're at the same temperature and there's no net heat flow between them anymore. Now, the way that heat can be transferred is basically by one of three methods. You have conduction, convection, and radiation. Okay, so this is purely conceptual. As we go through, I would recommend that you take good notes and look at all of the examples and videos that we have available. Okay, so let's start with conduction. So, conduction is the primary method of heat transfer within a solid or within objects that involve direct contact. Now, the reason that you see conduction with solids in direct contact is because conduction involves vibration from neighboring atoms transferring energy through collisions. Now, let me explain what that means. Okay, so let's take a look at this little video. So imagine, let's say you take a piece of metal and you put it over a flame. And imagine these blue dots represent the atoms inside the metal. Okay, so just use your imagination. Now, we know that temperature is a measure of the average kinetic energy of those atoms. Okay, so in other words, the higher the temperature, the faster they're going to be moving. Now, what's going to happen is when we put the metal over the flame, the atoms closest to the flame are going to gain energy from the flame. Okay, and so that means those atoms are going to start to move faster. They're going to vibrate faster. Okay, they're not going to fly all over the place because it's still a solid, but they are going to vibrate faster in place. And what can happen is these atoms in this row right here, closest to the flame, can then collide with or run into the atoms next to them. Okay, and when they collide, they can transfer some of those their energy to those atoms, and then those atoms can start to move faster, and then they can collide with their neighbors, okay, and so on down the line. Okay, so it's kind of like a domino effect type of thing. So watch this video. Okay, you can see the atoms closest to the flame starting to move faster and faster. They collide with their neighbors. Okay, and so slowly the atoms transfer energy through those atomic collisions down to the other end. Okay, and so this would kind of explain why if you put a metal pole over a flame, eventually you're going to burn your hand because heat is going to transfer from one end of the rod to the other rod. Okay, so even though the end that you're holding is not actually in the flame, you can still eventually feel that heat because it's heat is being transferred by conduction within the solid of that metal rod. Okay, so that is what conduction is. And again, you typically see conduction with direct contact because only if you're directly touching something can those atoms collide with each other. Okay, so that is conduction. Okay, so examples include, one end of a metal bar getting hot when you stick the other end in a fire, touching a hot doorknob and getting burned when there's a fire, and so on and so forth. Other examples would include situations where two objects are in direct contact with each other, especially if the two objects are solids. Okay, so what about convection? Well, convection is the method of heat transfer which involves a liquid or a gas, and basically convection involves convection involves the transfer of heat due to density, basically. And so what happens is if you take a fluid like a liquid or a gas, let's imagine the air, when you heat it up, it expands, and so it rises. Okay, and then as it goes up into the air, it becomes more cool. It cools down, it becomes more dense, and then it falls, and you get what's called a convection current. A simple example of convection would be if you take a match or a lighter, if you hold your hand over it, you can feel the heat radiate up into your hand. Okay, hot air rises. Okay, you probably heard that before, that hot air rises. Okay, the reason it rises is because of convection. Like I said, hotter fluids tend to go up because they become less dense. Okay, if you've ever cooked like pasta or rice or something on the stove, you might have watched the water boil. Okay, if you put pasta in a pot of boiling water, then eventually the bubbles are going to start to turn the pasta, because the bubbles go up and then they go back down and they go up and they go back down. Okay, that is an example of convection. Okay, when you're younger and they teach you about fire drills and stuff, they tell you, if you're in a situation where the room is on fire, you should get down on the ground, okay, and then crawl to safety. The reason they say that is because smoke and hot air rises up to the top of the room, and so there's colder air on the bottom of the room. And again, those all happen because of convection. Okay, so typically you see convection in situations involving a liquid or a gas, and the hotter fluid tending to heat up and then rise, and then eventually it's going to cool and become more dense and cause what's called a convection current. And then radiation. Okay, so radiation is the only method of transferring heat that does not require a medium. That means does not require solid, liquid, or gas to travel through. Okay, and so when we talk about heat transfer by radiation, basically the heat is being transferred by what's called electromagnetic radiation. Okay, specifically what's called infrared. You might have heard of infrared before. Now, all objects in the universe emit some type of infrared radiation. Okay, they emit what's called infrared photons, which are particles of light. And when those photons hit other objects, they are perceived as heat. Okay, and so if you ever, go into a room with a bunch of other people, everybody's giving off their own heat. Typically, that heat is in the form of radiation, because they're all emitting their own infrared photons. Actually, a human being emits about 100 watts, which is about the same as a light bulb. And so, like I said, all objects emit this infrared photon, so all objects can transfer heat by radiation. Now, there's no direct contact required, there's no medium required, and so this is basically the way that we get heat from the sun. So the sun creates a lot of heat because of nuclear fusion and stuff like that, and that heat reaches us through space where there is nothing in space. It's a complete vacuum. Okay, and so the way we get that heat is not through conduction or convection, but through radiation. The sun puts out like a bajillion infrared photons, and those photons, some of them come to Earth, and when they, hit the Earth, they basically transfer their energy to the Earth. Okay, and so you see radiation obviously in space, but also in other situations. And so if you've ever, gone to McDonald's and you see they put your food under a heating lamp, like your French fries or your Big Mac or whatever. After they finish cooking it, they put it under a heating lamp. Okay, that transfers heat down through radiation because the lamp is glowing and it's hot and it's giving off this infrared radiation. A radiator heating a room, that's an example of infrared radiation. If you've ever seen like those cameras that can show like temperature and stuff, those cameras work by basically seeing infrared photons. Okay, so that's how thermal imaging works. Okay, so those are the three methods of heat transfer. I'm going to link these two videos. I want you to check those out. They should give you a better understanding of how the different methods of heat transfer work. And then here we just have two kind of pictures showing you some more examples of conduction, convection, and radiation. Okay, and I will let you read the diagrams for yourself, but you can have more than one type of heat transfer in a given situation for sure. Okay, so quick example. Example 1 says label the following situations with the correct method of heat transfer. Now, just to make this easier for me, since I'm writing at home, I'm going to do this. Okay, I'm going to put an A if it's conduction. I'm going to put a B if it's convection. And I'm going to put a C if it's radiation. The reason I'm going to do that is just so I don't have to write out the word conduction, convection, and radiation a bunch. Okay, so let's see. A metal knife gets hot sitting on top of the toaster. you have two solids in direct contact with each other, that is definitely transferring heat by conduction. Okay, so remember you typically have conduction when at least one solid is involved. The second one says your state gets grill lines on it from where it touched the grill. Again, that is a context clue. Okay, direct contact, conduction. The heat you feel when you stand next to but don't touch a hot oven. Now, if you're not standing above the oven, which I don't know why you would, but if you're just standing off to the side, then that would be heat transfer by radiation. So that would be C. So remember that the context clue with convection is you typically see it with liquid gases and typically involves hot fluids rising up into the air. Okay, so for example, in the next one, it says the hot water in a pot rises to the top, gets cold, sinks down, and gets hot again. That would be convection. Okay, same thing with the last one. The smoke from a fire rises up a chimney. That would also be convection. Okay, because again, hot fluid becomes less dense, and as it becomes less dense, it rises up into the air. Okay, so anything involving heat rising, especially with a liquid or a gas, it's going to be convection. Okay, so that does it for the methods of heat transfer. Pretty simple stuff. Please let me know if you have any questions. And as always, I will see you guys in the next video.